Hello, today we're going to talk about chemistry, and this is going to be your first of several chemistry lectures. This is a 200 level anatomy course, which means we have an expectation that you have had some chemistry and some biology, either in high school or college. So this is going to be an overview of chemistry. It's what you need to know to be successful in this course. For many of you, it will be review from what you've had in high school. For some of you, it will be brand new. If this is brand new to you, you've never had chemistry, you will need to spend some more time on this. You will need to read the book. You may even need to email me and ask questions. But again, this should be a really broad overview for those of you who've had chemistry in at least high school. So the first thing we want to discuss is matter. And matter is anything that has mass and occupies space. So it actually has form, okay? So it can either be a solid in solid form, be in liquid form, or in gas form. And some things can change amongst these different forms. Think about water. When water is frozen, it can be a solid. At room temperature, it's a liquid. And then when it's superheated, it becomes steam, it can be a gas. So matter is anything that basically takes up space. Now, when we talk about matter, matter is composed of elements. And elements are things that can't be broken down any further. For example, carbon, oxygen, hydrogen. And these are your molecules, your elements, your elemental periodic table. I'm going to show you that in just a second. And when you talk about the elements, each one of them has their own unique properties. And so things that are physical properties that you can detect with your senses, you can see that, feel it, taste it. They're measurable, like gold has a specific look. We all know what gold looks like. It may have a chemical property, how it reacts with other molecules. How does it bond with other molecules? For example, hydrogen and oxygen, they can combine together to form water. So every element has its own physical property and chemical property. Elements are also, they're made up of atoms, and atoms are the building blocks for these elements. And all your elements have what's called the atomic symbol, which is just an abbreviation. So we take a 1 or 2 letter, and that's the chemical symbol for the elements. For example, instead of writing out carbon, you would just put C. Instead of writing out oxygen, you'd use O. Iron would be Fe. So don't get into the trap that your elements are always the first letter or the first 2 letters of the name of the element. For example, there is an element called calcium. Well, its atomic symbol is Ca, okay? And so that makes sense, calcium Ca, carbon C, okay? But you don't want to get those 2 confused. Just because it says carbon or calcium, don't assume it's C, one C, one Ca. So you got to remember that, which one's which. Iron is actually based on an old archaic name, ferrous, F-E-R-R-O-U-S. Ferrous is another word for iron. And so we get the abbreviation Fe for iron from the word ferrous. So, like I said, don't get caught up in learning the name and assuming that the first letter is its atomic symbol. This is the periodic table. I'm sure most of you have seen one of these before. And all this does is show you the letter, the atomic symbol, and the name for all the elements. And it's ranked in the order of size. So hydrogen would be the smallest one, and then all the way up to 108 and 109. These are some of your larger elements. And you're not expected to learn all of these. There's about 15 that are biologically important, and I'm going to show you those, and that's the only ones that you need to learn at this point. Okay, so there's a ton of them, but you only have to learn about 15, and I'll go over those in just a second. So when we talk about an element, these elements have structure, and it's called the atomic structure, and all elements are made up of subatomic particles of neutrons, protons, and electrons. Neutrons do not have a charge, they're neutral. Protons are positive, and electrons are negative. So think about positive and negative, and that kind of attracts each other. So all your elements are going to have neutrons, protons, and electrons. And depending on how many an element has determines its atomic number, or how big the element is. And so this would be hydrogen. It has 1 proton and 1 electron, but no neutron. And so if you could take hydrogen and look at it and see the subatomic particles, you would see it has 1 proton and an electron kind of orbiting around it. Helium is the next in size. It's just a little bit bigger than hydrogen. It has 2 protons, 2 neutrons, and 2 electrons. So here's your 2 protons, your 2 neutrons, and your 2 electrons orbiting around the central nucleus. And then you have another example will be lithium. It has 3 protons, 4 neutrons, and 3 electrons. So I'm not going to make you memorize, how many protons, neutrons, and electrons all these different elements have. Just want you to understand or remind yourself from earlier chemistry that you've had in high school or earlier college chemistry. Each of the elements has its own unique number of protons, electrons, and neutrons to give its particular atomic structure and atomic size. Now, the ones I want you to know, here's the list of your elements that are important in human anatomy and physiology. These are your biologically important elements. I've got the name and the letter, the atomic symbol. These you have to memorize. You have to know these. About 96% of our body is made up of these 4: oxygen, carbon, hydrogen, and nitrogen. Okay, about 4% of our body includes calcium, Ca, phosphorus, potassium, sulfur, sodium, chlorine, magnesium, iodine, and iron. Remember, I told you not to get in that trap of looking at the first letter to learn the atomic symbol. It's not always the case. For example, phosphorus and potassium, well, they both start with P. They both can't have the same atomic name or atomic symbol. Potassium uses K because the archaic or older name is kalium. Let me spell that out for you. Kalium. So that's where we get K for potassium. Sulfur is S. Sodium, Na, because the archaic or older name is natrium. Natrium, natrium. Chlorine is Cl. Magnesium, Mg. Iodine is I. And iron, Fe, for ferrous. And then just a small amount of trace elements. You have chromium, which is Cr, manganese, Mn, and zinc, Zn. So these are the ones I expect you to know on my exam. Sometimes I use the letter, sometimes I use the name. I expect that you recognize either one on my exam. So you need to learn all of these by their name and their symbol. Now, most of your elements can combine, and they combine with other elements or of the same type of element or different elements, and they form bigger molecules and compounds. And so the word molecule means that you have 2 or more atoms bonded together, and it's the same atom. So, for example, 2 hydrogens are bound together, and we would write that chemically as H2. A lot of times you'll see oxygen written as O2 because oxygen forms an oxygen molecule where 2 oxygen atoms come together and join and form the oxygen molecule. Now, if an element of one type joins an element of another type, we call that a compound. So, for example, water is a compound because you have hydrogen and water. 2 different elements join together to form a compound. Sodium chloride, which is table salt. That's 2 elements formed together. So sodium plus chloride equals sodium chloride, or a salt, to be a compound. So molecules are things, 2 or more atoms bonded together, like hydrogen and oxygen, H2 or O2. And then water is 2 or more different kinds of these atoms bound together, like H2O is water, NaCl is sodium chloride. And I expect you to be able to recognize these are really biologically important, water and sodium chloride, so you need to recognize those by name and by chemical symbols as well. All right, so we're going to finish this one. This was just a basic introduction to chemistry, and I'm going to move on in my next talk, and we're going to talk about bonding and pH and inorganic chemistry and organic chemistry and things like that. So if this video was brand new, you've never seen it before in your life, you need to stop. You go get your book and then start reading and refresh and learn about some basic chemistry. If this is review for you, great, move on. I'll see you on the next video. Thank you for your attention.